This is a pretty important notation type problem. They like these on the multiple choice in the free response. Everything we need, it's in your blue packet. On the second page, the back side of the second page in your blue packet has all your derivative notations, right? It shows you how to do your product rule, your quotient rule, and that's just how you normally do your product rule and quotient rule. First times derivative of the second plus the second times derivative of the first. Chain rule, if you have a composition function, you do the derivative of the outside function, leave the inside function alone, times it by the derivative of the inside function, right? And then the power rule, just multiply by the power, leave the inside alone, decrease the power by 1. So that's just a bunch of ways, and then you still times it by the derivative of the inside. So that's just a bunch of notation ways of how you're going to do the derivative that we're going to utilize in this problem right here. So, and everything we need is in our chart. Sometimes they give us charts here, sometimes they will give us like a graph, and we gotta make the derivative a slope connection if we need a derivative. But here it gives us original function, derivatives, all kinds of stuff. All right, so part A says write the equation of the tangent line at x equals 3. Now x equals 3, I gotta first figure out the y value. So I gotta take that 3 and plug it into this composition function. So I plugged in 3 for that x, and then I have to do f of g of 3. G of 3 from our table, g of 3 is equal to 6. That's how I get the 6, and then f of 6 from the table, f of 6, that's equal to 4. So there's our y value. So our x is 3, y is 4, there's our point. Now to get the slope, we need to do the derivative of that composition function. That's in your blue packet, that's your composition function, that's your chain rule, okay? So you're gonna do the derivative of the outside function, leave the inside function alone, then times it by the derivative of that inside function. That's whole key to the problem right there. Gotta make sure you get that chain rule notation down. And then it says at x equals 3. So I plug in 3 for those, and then they tell us from the table, you could do that on your own, you're good at that. G of 3 is 6 from the table, g prime of 3 on the table is equal to 2. It flat out gives us that. And then this is not, you can't go 6 times 2 and make that 12. This is 2 times f prime of 6. Now if they didn't give us the table, and they gave me a graph of f, I would have to look at what is the slope of that f graph at x equals 6. But since they give me f prime of 6 is equal to 5, that's just 5 times 2, and I get 10 for the slope. So once we have the point and the slope, boom, do your point slope form, there's the equation of the tangent line. And you're allowed to leave it like that. If you want to put it in a slope intercept form, you can, but you're allowed to leave it like that in the point slope form. Letter B gives us a quotient, which means I need to use my quotient rule derivative, and then we'll plug in 1 after. You always have to take your derivative first, use your notation, and then we're gonna plug in 1. So we're just gonna go denominator times it by the derivative of the numerator minus the numerator times it by the derivative of the denominator, all over that denominator squared, and then you're gonna take the 1, plug it in for all of those x's. And I really like this problem because the chart gave us everything that we needed to know. And so you just got to be careful because there's no calculator on this one. Make sure you get the right number from the chart. Make sure you do some basic arithmetic properly right there. But all those numbers they give us, so then you just gonna be careful with that. And you're allowed to stop it at -54/36. You can reduce it if you want to, but if you get larger numbers and larger fractions, they're pretty clear. Like they said, you're allowed to leave it like that. If you were to mistakenly like convert it to, reduce it to something that was wrong, then you're going to lose a point for that. But you got full credit for that right there. So if you see something kind of easy, you want to reduce it, fine. But if it's a little bit too large, you're allowed to leave it like that. And then letter C, you're integrating f double prime. So I think we know right away when we integrate f double prime, that's going to give us the first derivative. But see, you got that 2x right there. So we're going to do a u du. And so when I integrate f double prime, what I did, I let the u be that 2x, and then the du is equal to 2. So then I balance that 2 with the 1/2, and then what I'm left with is f double prime of u du. And then ignore this 2 and the 6. I'll talk about that in a second. But see, when you integrate f double prime, you're going to get f prime. You're going to get the first derivative. The 1/2 carries down. You balance that 2 with the 1/2. And then if you plug your x's back in, you get 1/2 f prime of 2x. That's what I got going on right here, f 1/2 f prime of the 2x. And then since I got the x's back in, I'm going to use the original numbers they gave me in between 1 and 3. So I'll plug in the 3, plug in the 1, get f prime of 6 minus f prime of 2. And then they give us these numbers from the actual table there. F prime of 6 is 5. And then f prime of 2 is -2. So I go 5 minus -2. That's going to give me the 7/2 right there. Now just another thought on that is like right here, like when we did UDUs, sometimes we wouldn't plug the x's back in. We would stop after we integrated, leave the u's in the problem, and then switch the x's to u's. You can do that on this problem right here. If you integrate the f double prime and get f prime of u, well, then you're not allowed to plug in the 1 to 3 unless you plug the x's back in, right? So like right here, if you wanted to just keep it in terms of u's, then you got to use this initial u equals 2x equation. If you take the 3 and plug it in, 2 times 3, that means your top number is now 6. And if you want to take the bottom number and plug it in, 2 times 1, that means your bottom number is now 2. And then you could plug in the 6, and you could plug in the 2, and then you go straight to this right there. So either way that works in your head, I think it's just good to kind of know both ways there. Chinchilla.